Tang, and I'm so excited to be able to present GenIA, our Genetic Immunology Advisor database, to you today on behalf of our development team, consisting of Drs. Andres Caballero, Laura Crisponi, and Michele Proietti. So we ask you to imagine a database that provides multidimensional information about genotypic data, clinical and phenotypic data, relevant references in published literature, functional data and functional studies, immunophenotypic information, paradigms and pitfalls relevant to the genetic architecture and landscape of that condition, and data about individuals and families who have been affected. Well, that database is really the goal of GenIA. One of the linchpins of GenIA is having the patient at the center to unify and integrate all of these different pieces of data. We also try to provide multi-level information and do not lose dimensionality at any of the levels. So for example, for every gene that is involved, we try to provide information about every single associated condition and inheritance mechanism, about the families that are associated with each of those particular clinical manifestations and the patients as well, and also the clinical terms and immunophenotypic information. GenIA, of course, based on the name, is meant to be particularly a comprehensive reference database for inborn errors of blood and immunity. However, we do believe that this also can serve as a paradigm model database for many other genetic conditions, and indeed any genetic landscape. So why do we need GenIA? Well, we can think of several good reasons, but we'll provide you with 3 here. I don't think I need to tell this audience that the inborn errors of immunity, genotypic and phenotypic landscape continues to expand so rapidly. Using just monogenic forms of CVID as an example, we can see that there's an incredible number of genes that continue to be associated with this quite heterogeneous clinical condition. And we are finding this to be true for many other clinical diagnoses as more and more patients receive upfront next-generation sequencing. So GenIA really aims to try to keep up with this burgeoning pace of discovery in a manner that may be more specific to immunology than a database like OMIM, and more routinely paced than a publication such as the IUIS classification. Of course, with the IEI genetic landscape, we encounter many challenges when we try to achieve molecular diagnosis for our patients. And even after achieving molecular diagnosis, there are still many, many questions that arise. And this, of course, is due to the incredible genetic, allelic, phenotypic, and mechanistic heterogeneity we see amongst IEIs. Our existing databases often are generalists in the sense of not being specifically considerate of IEI-related genetic landscape paradigms, or they may not be able to provide all of the dimensionality that we aim to achieve. And many of the opportunity is lost here for discovery. So we try to provide no loss of dimensionality, but also try to focus our efforts on an immunogenetic specific landscape. What does GenIA look like? So this is our user interface when you go to the link. As you can see, you can search via multiple different parameters, either by the gene name, the name of a clinical condition, the name of a particular clinical feature, a certain lab value, a certain cell type, or even the name of a paper, such as by PubMed ID. And in terms of the genes for which we have been able to perform full paper inspection, we usually keep track of that here. As you can see, we definitely are working hard, but appreciate a lot of help because we are trying to curate and catalog all of the scientific literature on known inborn errors of immunity, and that is quite a challenging task. But we feel we are up to it, especially with the help of the IEI community. As you can see here, we have many subjects per data set, and there is significantly many groups of data to be included. Our curators have a dedicated interface that makes it really easy to enter new information and to manually curate papers. So how can GenIA help the various stakeholders who take care of patients with inborn errors of immunity? Well, here are some examples. One of the questions that we're always concerned about in our field is, what is the diagnostic delay that we see for our patients? Well, you can see here from even mapping the information for different IEI conditions that there can be some with huge ranges of diagnostic delay and some that are more narrow and come to diagnosis faster. And this is the kind of natural history data that helps us ask why it is that some of these patients have such a long diagnostic odyssey and what it is we can do to address that. We are even able to provide aggregated data about the variability in diagnostic delay for patients with the same condition. And we can ask ourselves, well, what happened in those specific patient cases that led them to be diagnosed either earlier or later in life? And what were the consequences of treatment or other forms of management when those patients are diagnosed earlier versus later? Another question a clinical provider might ask is, well, I have a patient who was reported to have a candidate VUS that's predicted to be a missense substitution in a certain gene. Has this been previously reported? And this basically is a catalog of all of the published variants that we know about and their current classification. And the other question we often ask ourselves is, well, if we have a missense variant in a gene, has that class of changes been reported to be potentially pathogenic in this particular disease condition? And if so, which ones have been reported? What do they look like? Where are they located? Is there any similarity or difference that I can tell from the variant that I have for my patient? These are all searchable features. And how many patients with mutations in this gene have been reported in total in the literature? What are their ethnicities? What do we know about their ages? What do we know about their families? And how many of those patients have been reported and re-reported in certain papers? Because I think one of the things that we neglect to notice oftentimes is that we tend to overcount patients who are used repeatedly in aggregated reports. We also try to be very comprehensive in cataloging the spectrum of clinical presentations, because this is often crucial to help a clinical provider determine the relevance of a molecular diagnostic finding to their specific patient's clinical phenotype. So not only do we show what features were present or absent in a patient, we also note if they were unreported. And this is important to remember, that sometimes something might be missing from a literature report, not because the patient didn't have that condition or feature, but perhaps because it was not looked for. And we really do try to distinguish between those two situations. We also can provide information that shows you which specific patients and families in each paper and which specific patients within a larger pedigree or family tree might have been affected. And again, I show you here that you can see how many times a certain patient has been used in certain publications. We also try to show specific not only clinical features, but also laboratory features, and note certain presentations that are recurrent. And you can see that values are provided here for the specific serological parameters that we had available, as well as age that it was determined at. We also provide information for the physicians or geneticists who reported that particular condition, so that one may get in touch with those particular providers with additional questions. We also provide information about the functional consequences of a condition, and I think you can see here that after seeing the various different assays that might be used for a particular condition, one gets a sense for which robust assays might be preferred for evaluating the functional consequences of a particular variant. Here you can also find literature on specific genes and variants, and also specific literature that shows particular functional studies, and also even the stimuli that were used for the same assay. You may also ask, well, can I find papers associated with a specific gene or variant just like ClinVar presents them? Well, oftentimes ClinVar contains variants that may not actually be published, and we definitely denote those in our database wherever possible. ClinVar also links to many papers that may be more generally associated with the gene or the condition, but not actually with the specific variant that's cited. And because we manually curate our literature, we make sure that there are no misleading citations associated with any variants or genes. Another very useful situation is for the clinician to help derive differential diagnoses. So you may want to ask yourself, well, I have a patient with the following clinical features. What are the most likely monogenic etiologies? And because our clinical spectrum is a bit more comprehensive for IEI-related conditions, we can provide a more detailed and often a more accurate differential diagnosis than a website like OMIM. Another thing that providers might be curious about is how different serologies or different immunophenotypic observations might correlate with each other, or how they may affect each other. And so one relevant question to patients with FOXM1 deficiency, for example, is if a patient has low T cell counts, does that generally lead them to also have low B cell counts? And we can see here that the correlation is not exact. Can we also use GenIA for variant prioritization if we're analyzing exomes and genomes? So because of the dimensionality of data that is provided, you can see that we have significantly more families, more variants, more papers, and more patients cataloged in GenIA for any given condition than either OMIM or ClinVar. And you can see that our clinical annotation is more thorough and complete than either HPO or OMIM is able to provide. Just as an example of this, for ARPC1B deficiency, we've listed here the most prevalent findings in the 29 patients that we've thoroughly curated in the literature. And you can see that this is not something looking in HPO would have been able to provide, as 9 of the 10 most common signs are actually not even included. Similarly, for OAS1 gain of function, we have many situations that actually illustrate this concept. So a lot of N of 1 conditions exist in the IEI genetic landscape, and oftentimes many of these conditions are not recognized as such in OMIM, and the variants are not recognized as pathogenic or likely pathogenic in ClinVar. And part of this is because there are many assumptions made by the ACMG classification criteria that we all use that are not well suited to the IEI genetic landscape. Nonetheless, we cannot discount these conditions or these variants, and so we try to make sure that there is comprehensive information about all of these conditions. Furthermore, you can see here that we provide significant amounts of clinical annotation for conditions that are sometimes absent in HPO database. And in summary, this is just a quick sneak peek of what GenIA is able to do, but there are many other ways in which this can be used, one of which is currently being discussed with ClinGen, because a lot of the information that can be provided about penetrance and other features of inborn errors of immunity can help ClinGen curators develop new and better guidelines for IEI gene variant classification. So as GenIA continues to grow, we would love for you to join us on this quest. Whether you are a clinical provider who cares for patients with specific inborn errors of immunity, whether you're a researcher who pursues certain genes for your research studies, whether you are an investigator who's trying to develop novel treatments for IEIs or repurpose pre-existing treatments, whether you're someone who's interested in conducting natural history studies or clinical trials towards this end, whether you're someone who's performing genetic analyses either for clinical diagnosis or for novel IEI gene and variant discovery, or whether you're a patient's family or a patient advocate group who cares about this group of disorders, please talk to us about all the ways in which you can get involved. So this is our team so far. We would love to have you be a part of this already multi-institutional and multidisciplinary collaboration. Please reach out to us with any questions. Thanks so much for your time.